to my YouTube channel. And on this specific video, we're going to be focusing on training CIFAR10 dataset using the Pytorch framework. And to begin with, we're going to start by importing the necessary libraries. So the first step here, I'm going to say importing libraries. The first library I'm going to import is Pytorch. And then from Pytorch Fusion, I'm going to import datasets. Again, I'm going to import Pytorch data. So I'm going to import Pytorch.utilities.data as actually it's supposed to be from Pytorch.utilities.data. I'm going to import data loaders. I'm going to import data loader again from Pytorch Vision. Transform. I'm going to import tensor, and I think this is supposed to be transforms if I'm not wrong. And then again, I'm gonna import from I'm gonna import neural network. And at the same time, I'm gonna import optimizer. So these are just the basic libraries we need to train our CIFAR10 dataset. So the second step, which is step 2, gonna be downloading the dataset. So downloading dataset from Pytorch, and what we're gonna do, we're gonna give it label train data, and here we're gonna call datasets, and then CIFAR, our dataset is CIFAR10. The first argument will be our root directory, let's say data, and then we want to download the dataset. So let's give it a Boolean rule, and then we want to train, so we're gonna have that one as true, and then transform, it's gonna be the tensor. The same case will be for our test dataset. So I'm just gonna copy this and copy it here, but instead the variable name will be test for our test data, and instead here we're gonna have false. And it's gonna take a while to download the dataset. And what you're doing, we are downloading the CIFAR10 dataset and having the trained data and the test data. After downloading, we have the root directory, which will be data. Then we're gonna be downloading and transforming this data to tensor. So the next step, which I'm gonna have as step 3, will be now the data loaders. This is very essential to kind of like help in our training. For instance, to patch our data during training process, which makes it easier if you have large number of data sets. But before we do that, let's check the shape of our data. So what we're gonna do is for images and labels in trained data, for instance, let's get a sample from this trained data. We want to print image shape, and let's adjust the size of one sample and see the size of the images in that dataset. And the size is 32 by 32 and 3 channels. So you really know what kind of data we have. So this probably is an image data. So the next thing is to use the data loaders. And to use the data loaders, the first thing we're going to define is the batch size. So let's say we have a batch size of 64. Let's have another variable, maybe train loader. And in this train loader, we're gonna have our data loader. So we already had our train data. And from this, we have our batch size as the batch size. And then maybe let's shuffle the data set. And then the same case will be for the test data. So I'm just gonna copy this and have it down here. But instead, I'm just gonna call this one test loader. And here it's gonna be test data. So you're kind of like having it in a batch to make it easier for training process. So we have it. So let's kind of like check the sample size or the number of data set that we have. So what we're gonna do, let's call len and then it train loader the data set and see. So for a train data set, we have like 50,000 samples. And I think the same case would be for the test. Let's see for the test data set. So I believe in total, just a minute. So for the test, we have 10,000 data set, and for the train data, we have around 50,000 data sets. Now, the next step will be, which I'll call step 4, will be the neural network. Now for this, let's just subclass the NN module. So here, let me just call it network. Network, and I'm gonna be subclassing it from NN module. So I'm gonna call it NN module. And then from here, I need to define to initialize. So after initializing, I need to define my layers. So the first layer, I'm gonna be using the I'm gonna flatten the data since it's an image data set. So to flatten it, I'm gonna use the NN flatten, and this is gonna multiply this one. Instead of having individual height, width, and the channels, we're gonna multiply all of these to get one value from the input. And the same now to define our sequence, all our layers. So I'm gonna use the sequential layer. So sequential, and here I'm gonna use the sequential method. And this is just another way of defining your neural network. And the first thing I'm gonna do is I'm gonna have a linear layer, and in this linear layer I wanna multiply the channels, the width, and the height of the image, and then from that probably have an output of 784. Then in between I wanna have an activation function, which I'm gonna use the rectified linear unit. Again, another linear layer, and this one is gonna have an input of 784 since it's the output of the first layer, and probably when we just have, for illustrative purposes, an output of maybe 512, and then let me just define another integration function in between, rectified linear layer. And then I'm gonna be having another layer here, and this one I'm gonna use this as my input since it's the output of the preceding layer. I'm just gonna have it as 512, and probably let's say an output of 10. indicating the 10 classes we have. And that's the first, the forward function. Let's define the forward function, sorry. So, the forward function is gonna have self and x, and here we're gonna have our x. We're gonna first of all flatten our values to uh, one value from the height and width and channel. Instead of having three values, we're gonna have one by multiplying all of them together. So that's the first step we're gonna do, and then the second step we're gonna pass this, the sequential layers. So here I'm gonna have sequential, and then let's return x. After this, we need to instantiate. We need to instantiate the class. So what we're gonna do, let's call it net. So here you're gonna have a network is net. Once we have defined our classes, so the other step is gonna be kind of like a device, or what I will call the CUDA GPU, loading to GPU. And to do that, we can define a variable called device, and CUDA if torch dot CUDA dot is underscore available. Use CUDA if torch is available, else use CPU. And the first thing we're gonna load our network, our neural network, to the CUDA device. So here our network is gonna be net dot to device. So that is the first thing we're gonna do. And then after that, the sixth step is gonna be defining our loss function and our optimizer. So here we're gonna be like define loss function and optimizer. So when here I'm gonna call my loss function as criterion, and here I'm gonna use the close entropy loss. So close entropy loss. And for the optimizer, I'm gonna use the stochastic gradient optimizer. So it's supposed to be optim std stochastic gradient, and my model, which is net.parameters, and then other arguments which are optional. For instance, the learning rate, which you can put an argument if you want, or you can just use the default. After this, we need to, the seventh step, we need to have define our train. So to define that, I'm gonna have train, and I'm gonna have some argument inside train. The first argument is gonna be my data. The second one is gonna be my model, and then my loss function, which is criterion, and then I'm gonna have my optimizer. So for these arguments, the first thing I'm gonna do, I'm gonna set my model to train mode because some parameters such as optimizer behave differently during training and during testing. So I'm gonna first of all set to train, and then the next thing I'm gonna do is for every batch, my images and labels, I'm gonna in the data loader. The first thing I need to do, I need to set the images and the labels to the same device. So my images and labels need to be in the same device. So I'm gonna have the images set to GPU, and I'm also gonna have the labels also set to GPU. And then I need an output prediction. So here, based on the images that I put, and from this, I need to get the loss based on my loss function. So here I'm gonna have output compared to my labels. And based on that, I want to make sure that I zero the gradient. So what I'm gonna do is I'm gonna call optimizer. So every time a new gradient is created, it starts from zero. So I'm gonna zero the gradient. The second thing is I'm gonna have the backward. So backward and optimizer step dot step. And from this, I wanna from every 100 batches, I wanna output the loss. So what I'm gonna do, so if uh, the batch is 100, here I wanna have my loss is loss dot item. So I wanna output this loss. So what I wanna do is I wanna print the loss. So I'm gonna use the string formatting. So loss here is equivalent to loss. So after every 100 batch, I will be outputting the loss from the training process. So after defining that, the next step will be, which is the 8th step, will be to define the test. And to do this, the same case. So we're gonna have some arguments, and here the same case, we're gonna have the data loader. We also need the model, and we also need the loss. So from here, we also need to make sure that we set it to evaluation mode. And then let's get the size of our data. So here it's gonna be len data, our data loader, the data set, and let's get the number of batches also, which you can get by also calling len and then the data loader to get the number of batches from the data set you have. And for this, so for every for the images we have and for the labels also we have in the data loader, we need to set these to the images again, and the labels we also need to set them to GPU. So here we can have images to device and labels also to device. And before we do that, let's since we're gonna be computing the loss, the average loss and the accuracy, let's just have another variable here, test loss, and let's initiate it from 0. Then let's have the accuracy also here starting from 0. So after setting that, we also need an output, and here we're gonna use criterion loss. So here we have the output, and we also have the labels, and based on this, we're gonna compute the test loss. So our test loss will be addition to our loss dot item. And to get this loss dot item, so sorry, this one is supposed to be actually loss, but to get the output, you need the model. So yeah, sorry. So here we need the model, which is having the images. So we need this output prediction, and we compute the loss. And in this loss, we sum it up to this test loss, which is going to be accumulating the losses which we get from the prediction. After this, we need now the accuracy. And the same case here, we're gonna be adding it up. And for this one, we're gonna still be using our output. And in this output, we're gonna be checking for the maximum value. When we index in each row, we're gonna be checking the maximum value and comparing it with our labels, whether the maximum value is equal to our label, which is y, and our case is actually the labels. So if the maximum value is equivalent to the labels in each row, then we need to get that into float. So this first part is gonna output whether it's true or false that the maximum value is equivalent to the labels. And if it's true, it's gonna convert this to 1. And if it's false, it's gonna convert to 0. So we're gonna convert that to 1, and then sum all those predictions. And after summing it up, we're gonna store them to this variable accuracy. After that, we need to kind of like output our results. And what we're gonna do is here, just a minute. So okay, so what we're gonna do here is I'm gonna hit tab there. So what we're gonna do here is let's have our test loss, and this test loss is gonna be division by the number of batches. So we're gonna be computing test loss based on the number of batches. So let's, in every batch, what loss have we obtained? And the next thing is gonna be accuracy, and the accuracy is gonna be divided based on the sample size, how much data we have or how many samples we have. So we're also gonna divide it by size, and we want to print uh, the average test loss. So I'm gonna call it the average loss. Yeah, I'm gonna call it average loss, and it's gonna be the test loss. And at the same time, I wanna output the average accuracy, and again here I'm just gonna call the variable we had as accuracy, and that's it. We have defined our test function. So the last step, which is step 9, is gonna be the training. And the training, what we need is the epochs. So assuming we have like 5 epochs or 6 or 10, the number you want. So for every epoch, yeah, in epochs, we're gonna call our train. And our train, we need the train loader, which is our dataset. We also need our model, which is net. We also need our loss, and we also need our optimizer. For the test, we need the test loader, we need the model, and we need the loss. So here let's output, like we are done when we are done the training process. So but for I, so I forgot image. No, actually for I image. So in the training process we begin, and we are getting the losses after every 100 batches, and after that the training is over, we get our average loss, and we also get our accuracy. We have trained our model for like 5 epochs. So basically this is how you train on Pytorch dataset. There are actually a number of datasets. What we just use is just a sample, the CIFAR dataset. If you want to check the Other types of data sets, you can just call the dataset class in Pytorch, and there are different types of data which you can use to train. You can use the Caltech dataset. You can use the fashion NIST dataset. So there are a number of datasets which you can use to train your deep learning model. The ones which are provided by Pytorch. So basically that's it. That's just a simple way to train the CIFAR10 dataset. And thank you for watching, and until next time, peace.